In this example, we're going to find the volume that's generated by the region that's bounded by the curves below, and we're going to rotate it around the line y equals 9 to generate that volume. So this green curve right here is the curve x is equal to y squared. This pinkish line is the line y equals x. And this purple line here is the line y equals 9. That's what we're going to rotate this around. When we look at the area that's bounded by these two curves, we get this tiny little sliver or wedge. And we need to rotate this around the line y equals 9. So when we rotate it, if you can follow my highlighter here, when it comes around like this and rotates around the line y equals 9, there's going to be a big area in between. So we have this little sliver that looks like this. This is our solid piece that is bounded by the curves. And then here's the line y equals 9. And so we're going to rotate this piece. Remember, there's going to be a big area in between. Let's see if I can do this and make it look nice. Not too bad. And then we're going to have, it's going to curve like this and come around. So this is the direction we're going. This is that region that's bounded. So we're going to have this big opening in the middle. When we take a slice, let's do it in blue here. When I take a slice this way, we are going to get what looks like a washer because of that big open space in the middle. So if we want to find the volume of this, we need to find the area of this big circle from this slice and then subtract out that center part where there's nothing there. This is the center, and if we need to find that radius, we're going to go from here to here all the way to that outer edge. The distance from the center to this edge is the radius. So that would be 9 minus, and then this line right here is y equals x. So the radius of the big circle is going to be 9 minus x. Now when we look at the radius of the inner circle, I'm going to color code that in red. We're looking at it from here just to here. So that's going to be this center out to this piece right here. That's the edge of this green curve right here, which is x is equal to y squared. Because the way we're making our slices, we want to make sure that we're writing this in terms of x. So when I take 9 minus to find the distance from the center out, 9 minus whatever this curve is, I have to write that curve in terms of x. So I'm going to write it as 9 minus the square root of x. When I take this curve right here and I write it in terms of x, that's what it is. It's the square root of x. Now when I set up my integral, I'm going to find the area of the outer, subtract the area of the inner. So that's going to be pi r squared. So I'm going to take 9 minus x and square it. And then I'm going to subtract the area of the smaller circle where there's a gap. That's going to be pi. Then the radius would be 9 minus the square root of x. This is the radius, and then we have to square it. And then, of course, I'm running out of room here, but I'm going to squeeze it in. Dx. So now we just got to figure out what our upper and lower limits are. So the area that we're integrating to create this volume, if I look at these intersection points of where these two curves meet, that's going to be from 0 to 1. So I'm going to set up my integration with a lower limit of 0 and an upper limit of 1. So this is what I need to calculate to find the volume of this region that has been rotated around the line y equals 9.